Hello, friends. Welcome to the Nexus Podcast. I'm your host, James Dice. Each week, I fire questions at the leaders of the smart buildings industry to try to figure out where we're headed and how we can get there faster without all the marketing fluff. I'm pushing my learning to the limit, and I'm so glad to have you here following along. This episode is a conversation with Carmel Pratt, Director of New Construction at Bright Power and NYC. We talked about embodied carbon emissions and how leading construction teams are balancing embodied carbon with operational carbon emissions over the life of a building asset. Then we zoomed in on the operational side, and I got Carmel's take on the challenges ahead at electrifying our buildings. This was super insightful. Please enjoy. Hello, Carmel. Welcome to the show. Can you introduce yourself, please?
Thanks. Yeah, I'm Carmel Pratt, Vice President of New Construction in New York at Bright Power. I have a background in architecture and a passion for sustainability, and I lead a bunch of teams at Bright Power that provide consulting services in the energy efficiency and sustainability space for ground-up new construction projects as well as rehabilitation projects, mostly in the 5 boroughs of New York City.
Cool. Can you tell us about your background before Bright Power?
Yeah, so prior to joining Bright Power, I was the sustainability director at the Levy Partnership. And before that, I was a sustainability consultant at Stephen Winter Associates. And before that, I was installing insulation at Habitat for Humanity in Paterson, New Jersey. I have been working in this space for a little over 8 years now. Again, managing teams or managing projects directly that are pursuing certification standards, green building certification programs, incentive programs. I've done everything from, like I said, installing insulation to doing inspections and performance testing post-completion. I do a lot of design reviews and energy modeling and general consulting in the space.
Got it. Tell me about what installing insulation was like. What is that like day to day?
Yeah, so it's, I always tell people, like, if you get out in the field and you see where the rubber hits the road, it really starts to connect the dots. And so I think that was the kind of beginning of my passion of understanding that what you can theorize, with my academic background in architecture is not always what happens in situ, right? When you go to install a bead of caulk and you're trying to connect wood to a fiberglass window, for example, there's a lot that goes into that. So I say installing insulation, actually it was a lot of like weatherization work, so air sealing as well. And I managed the Energy Star certifications and the overall what was called like green services or energy efficiency of habitat builds. So I was doing the work. I was also teaching volunteers that had like zero skills in terms of manual labor skills to do air sealing and insulation work that had to be of a higher caliber because we were getting inspections from an Energy Star and HERS rater at the time.
Got it. So I have a selfish question. I'm thinking about doing sealing. My house was built in 1959. I'm thinking about basically doing all the insulation and weatherization myself. What do you think about that?
I think if you're thinking about fiberglass, cover your body head to toe. It's the most annoying stuff to work with, and also I just wouldn't recommend it as a product. And we'll talk about that like later in this conversation. But for various reasons, one of them being the embodied carbon impacts of fiberglass as a material. It's not fun to work with or breathe in. Definitely wear a respirator if you do plan on using it. But it's definitely humbling work, and I think it's totally possible for someone to DIY it if they have the time and they really put in the effort to follow manufacturer recommendations for installation. It's the type of thing where you can get a really good product, but if you don't install it correctly, it's not going to work in the way that it's intended. So depending on, I don't know if you have thoughts already on what material you want to use and what kind of air sealing materials and techniques, but it's definitely, something you want to give yourself enough time to do correctly and kind of do it once right and not have to worry about it again.
That's helpful. We won't go down that rabbit hole, but that's very helpful. So I was stalking you online and saw that you got asked in an interview, what do you want to be when you grow up? And you said an architect or a jam band singer. And architect sounds normal. Jam band singer, I'm wondering, I'm a fellow jam band fan. What jam bands do you like or did you like back then?
I'll just argue for a second that an architect being normal over jam band singer is like
For this podcast.
dependent, yeah, dependent on like your situation and where you are in life. But I followed, I guess, most recently like Twiddle and Mahali, which are, I guess, more local to our East Coast,
Okay. Yeah, I've never heard of
Northeast.
those.
Yeah. Not a fish fan. Sorry guys, but just not my thing.
Neither
So
am I. Neither am I.
yeah, I'm more just local bands and people that I can just pick up and jam with myself.
Very good. I very much followed Humphreys McGee and Soundtrack Sector 9 throughout college. Saw them both many, many times. I think those are in the jam band category. Am I right?
I don't even know that I know what would fall in or out of the jam band
Okay.
category. I
Yeah.
haven't heard of those two that you mentioned, so I feel like
Huh.
it's, you know, to each their own and maybe very geographical.
All right. All right. Cool. Well, let's jump in. So, Bright Power, can you tell us more about, in general, what they do as a whole?
Yeah, so in general, Bright Power is a energy and water management partner. We have a whole arm. We've been around for about 16 years. Started in New York, spread to have an office in Oakland, California, as well as a lot of kind of satellite people and offices across the globe actually now, and definitely doing work nationally. Started out doing a lot of existing building auditing and then moved into the space of utility analysis and like ongoing monitoring of energy and water in buildings and created a whole online platform for utility monitoring called energy scorecards. So we have a lot of clients that subscribe to that for utility data aggregation, and analysis and kind of ongoing monitoring. That is admittedly a whole side of the business that I'm like way less involved in and in the know of, but that is in terms of the folks out there that are interested in data and technology. We provide a software product and a service through that. My side of things is a lot more kind of in the consulting space, in the project design and construction, kind of like I mentioned before, everything from boots on the ground inspections and performance testing to design consulting, energy modeling, building commissioning, both on the existing building side as well as on the new construction side. And in the New York office specifically, we also have real-time energy management, which is like a bunch of engineers that go in and put sensors and like information of things, kind of tech that gives real-time feedback, and they're monitoring kind of abnormalities or things that are going on in the building and giving feedback to the building operator or owner to try to draw down energy and water.
Mm-hmm. Yeah, by the time this podcast gets published, we will have had someone from NYSERDA coming on to talk about the R10 program right before this. So great timing there.
Awesome. Yeah, that's our big partner in that work, and really how a lot of those projects are getting funded right now is through NYSERDA's RTEM incentive programs. So
cool.
Yeah.
So we're gonna not talk about that side of the business that you're not involved in. I want to jump in and talk about. So we had Stacy Smedley on the podcast last summer, I think it was, to talk about embodied carbon. We haven't really revisited the topic since then. So I think it'd be a great opportunity to dive into that with you. The place I think it'd be fun to kick off was, we were talking about this before we hit record, how to think about, if we think about an organization, a building owner organization's carbon footprint, what percentage of their building footprint is operational versus embodied? I know it depends, right? The engineer's favorite answer, it depends. But like, can you talk about what goes through your mind there and what does it depend on? And how do we sort of get to a general conceptual understanding of what's in what bucket?
Yeah, I think where we have to start is agreeing on how we frame kind of where we start and stop the ticker that we're calculating or adding up embodied carbon and operational carbon. So that's the first place, is like, are we looking at every piece of material from its extraction through to when it comes on site and its afterlife? Is that the full life cycle that we call it of of that, product, or is it just from what we call gate to gate, which means the moment that it comes on site versus where it came
Yeah.
from beforehand. So it's depending on how you cut that, the I guess the percentage can change drastically. And the other factor in that framework is time, right? So
Right.
where do we cut off how long we are monitoring the operation of a building, or how long that building is going to be online
Okay.
and expending energy? The reason that embodied carbon is so important right now is because if we look at that time frame as a shorter 10, even 20-year time frame, the I guess seesaw of the weight of embodied carbon is a lot heavier than the
Mm.
operational carbon if we're
Okay.
thinking about a building being online for 100 years. So Architecture 2030, which Stacy from Skanska is very involved in, and Carbon Leadership Forum have tried to put together framework for putting a number to this and getting this kind of urgency out around the
Mm.
time frame, where they see that in the next 10 years, as we draw down the operational carbon side of things, our embodied carbon piece of the pie is going to be closer to 50, if not more, percent of overall what we consider to be building emissions, carbon emissions from the building sector. So when you put that time frame on it, that's where the urgency comes in, and that's where the percentage and the amount of embodied carbon actually skyrockets, because now we are looking at a longer life stage of the products that go into the building and a shorter time frame for what we consider to be the operation of the building, right? It
Right.
takes 2 maybe years to put a building up, and then it is up for 100 years, but how much carbon went into a very short 2 years that went into building that building?
Right. Right. So if I'm drawing like this box around both, right, the building of the building and the operating of the building, the shorter I make the operational phase, you're saying if we're drawing maybe a 10-year window around the operational phase, that means the embodied bubble is much bigger as a relative part of the whole. Is that what you're
Right.
saying? Yeah. But if we draw that operational out 100 years, the operational carbon ends up swallowing a lot of the embodied carbon at that point.
Depending on what the weight is of,
Okay. Yeah.
whatever you're looking at, calculating embodied carbon for. And that really, all of these questions is what turned into a little kind of passion research project that myself and a partner architect started to get into, is like, how are we calculating both these things, embodied and operational carbon, and then what does it look like when we put a 10-year time frame on it versus the lifetime of the building, and where then can you pinpoint the point in time where that shift in the weight of carbon on the embodied side versus the operational side actually, like I said, shifts the seesaw sort of over
Got
to
it.
the other side.
Got it. So anyone that's out there saying one is the more important than the other, though, if we look at the big picture to that question, it just depends on those couple factors you mentioned. There's no one answer at this point.
There isn't. Balancing the two is important, but I would say for where we're at right now in terms of our 1.5 degrees Celsius over our global
Mm-hmm.
carbon emissions, the urgency is in the time frame, right? Like, we don't have 100 years that a building's online
Right.
to kind of get our return on investment in what we're putting into the building now. We need
Mm-hmm.
to look at what is this in the next 10 years, because we can't get another degree Celsius above
Yeah.
our, carbon expenditure globally. So when we look at it, also when we kind of zoom way out, forget the building, look at the planet, and what do we have in terms of that equation,
Yeah.
in carbon expenditure, that also begins to highlight the importance of the embodied carbon side.
Got it. So how do you balance the two then? What does that even mean, I guess, to begin with?
Yeah, so that means asking these questions, looking at every single thing that goes into the building. I'd even argue, like, the transport and the energy used in making the decisions of what goes into the building, and looking at these things and deciding where it makes sense to. Here's an example, but
Okay.
at what point, if we take the roof, for example, at what point in the increase of insulation at the roof, where we're potentially adding a bad material like plastic foam to get a better thermal performance on that roof? At what point do we have diminishing returns operationally where we can never buy back the carbon of 2 additional inches of plastic foam insulation? And so that's where you start to balance thinking about long-term operation of the building. Are we really in 100 years going to make back the carbon that was expended in that 2 inches of plastic foam that we added to the roof?
Got it. Okay. So what's that analysis look like on a new building or an existing one? It sounds like it's a lot of like what Stacy talked about, these different material models, right? And then there's on the operating side an energy model that you can then unite the two into some sort of decision support system or whatever, however you want to call it. How does that work in practice?
Yeah, so in an ideal state, we would marry the two and simultaneously be calculating and tracking embodied carbon and operational carbon in real time. And actually, I will shout out the Passive House Institute PHI energy modeling software, which is called PHPP. They came out with a new like plugin. They call it the Passive House Network Ribbon, and it's a plugin for the software that actually pulls the material emissions database from the work that Stacy was involved in the EC3 tool, which is the building transparencies. Like it's a database of EPDs, environmental product declaration, for a bunch of products, and it pulls that data along with EPA emissions data for like sourcing energy and other things right into your energy modeling software, so you can simultaneously calculate all this and see in real time that seesaw and the levers going up and down with different material use and different design strategies that you're working with. We in our study had to do this a lot more manually. We were not working in this ideal state in that software. It just recently came out, so we're excited and are starting to pilot it. It's pretty new to us. So what we were doing is we were manually pulling data from that EC3 tool, as an example, just calculating volume of material, whether it be cement or roof insulation or whatever it is, getting a carbon equivalency number. And we had a spreadsheet going where we were plugging in on one side the embodied carbon calculations from an outside tool like EC3, and then had an energy model run kind of at the same time where we were making those changes, whether it was increasing insulation or changing the material, and then plugging that into our spreadsheet and kind of comparing things manually, old school sort of way.
I think anyone that grew up in the days of Excel-based optimization, we've all done the sort of manual iteration. Hopefully there's some sort of software. That's what machine learning is supposed to be able to do at some point, is to optimize these things for us. But you're essentially optimizing for both at the same time is what we need to get to, is what you're saying. And it sounds like if you don't, you could be solving for one of them at the expense of the other. Like you're saying, if you had a really high carbon dense insulation, you're solving for the energy, the operational side, but you're not solving for the embodied side. Does that happen a lot today?
Exactly. Yeah. It's in the last 20 years, there was this huge movement and push on the operational carbon side.
Right.
And with Passive House, on the very positive side, Passive House created these super insulated homes that allowed us to downsize our mechanical equipment and have very low heating and cooling loads, which is great operationally, but we threw in a ton of material to do that on a building. And so we were doing that. We've been doing that, are continuing to do that for how many years? So at this point, it's kind of like taking a step back in what we've been focused on, which is the operational carbon side. And really your question about like, where do you find that balance? It's important to create, again, a framework of like, Passive House gives you a nice framework of targets to meet for heating and cooling loads, for overall site energy. And so if you're still within those targets and you're meeting the Passive House intents, that's a good framework to say, okay, like we got here. Yeah, with a little bit of renewable energy, we can get to net zero with this design. We don't have to add more insulation just because it's going to bring down the heating load a little bit more. We can make that up. And as we clean up our grid and as we clean up our electrification, like our options for electrifying our mechanical systems, we can get to a net zero state scenario without just like over insulating and over engineering a building.
Mm-hmm. How does this thought of balancing EC and OC, how does this apply to existing buildings?
Yeah, actually, an argument is that like existing buildings are the best place to start when you're looking to bring down embodied carbon.
Okay.
Use what you already have, right? So the most amount of embodied carbon is typically spent in the superstructure of a new building.
Yeah.
So that's, whether it's cement or mass timber or whatever it is, or just even wood frame buildings, you have a lot of expenditure there. So if you can use the good bones of an existing building, off the bat, you're cutting out a lot of embodied carbon of new material. And there's existing buildings come with all of their own issues and tricky conditions, and sometimes there are limitations to what you can do on the interior versus the exterior, for example, on the envelope. But it is definitely, general sentiment is the more you can reuse in a strategic way, the lower your embodied carbon number is going to be.
Got it. Okay. Cool. So tell me about the study. Can you talk about how it came about and who funded it and all that?
Yeah, so this study is on a project, a development in Brooklyn and New York of two buildings that are affordable housing, mid-rise buildings, like 35 to 40 units each building. They're situated across the street from each other, and the owner and the architect and ourselves were always pursuing passive house certification for these buildings, but the architect, and I'll shout out my true partner on this study, which is Sarah Bayer at an Architecture and Planning. The architect and myself both came from this kind of like personal passion interest in embodied carbon and decided, hey, let's really look at this on this building. How can we fund some of the time that's going to take to do these calculations? And so those buildings applied for an award through NYSERDA. You'll speak to in a couple of weeks. It sounds like they had a competitive solicitation program called Buildings of Excellence. It's now in its third round. It was at its second round when we applied with these buildings, but it essentially funds the type of technical assistance that goes into designing low carbon buildings. It also intends to fund the gap that might be in the cost of upgrading envelope or other building systems to get to that low carbon target. And in this case, our application really highlighted the work that we wanted to do in looking at the embodied carbon side of things. So that award money kind of went into this. A lot of our kind of time and just passion for this has gone into that. And yeah, like I mentioned, so the architecture partner MAP, Sarah Bayer, for the most part, was looking into doing the calculations in terms of getting, like I said, the volumetric kind of numbers from whatever they were specifying for different components of the building. And we were in the background making all of the adjustments kind of in real time on the energy model. Every time we tweak something one way, change a material, whatever it was, and giving that feedback. So yeah, it worked really nicely that we could partner in that way and kind of each take a piece of the calculation of the pie, so to speak. But what we're looking forward to now is having that capability in one software, like I said, to be able to do that calculation. One person, could be getting all that information and inputting it and outputting some useful information to make decisions.
Cool. So what was the overall intent of the study? And then what did you find from it?
So the intent was just to really draw down wherever possible embodied carbon and just to understand what the weight of it was, right? We knew that we needed to meet the passive house targets. So like that created sort of walls for us to stay within and bounce around. And within that, we were just free to like look at alternatives for materials, see where we could, like I said, reduce, roof insulation or wall insulation or whatever it might be, play around with triple versus double pane windows, and that was the intent there, is to see how low can we get embodied carbon and still hit passive house goals and still show this nice low operational carbon, low site energy use intensity with a significant reduction on the embodied carbon side.
Cool. And then what was the results?
So the result overall is that we found some really what we call low-hanging fruit design decisions that helped to significantly draw down embodied carbon without changing. We didn't recreate any like big innovative whatever thing. We had to stay within the bounds of a cement CMU like block and plank superstructure. So in that sense, we were maybe a little limited in terms of not being able to use bio-based material like wood and other kind of carbon sequestering material in our superstructure. We were able to find, for example, a CMU supplier that does carbon capture within their manufacture process. So if you're using cement CMU, find the best cement possible that lowers inherently in their manufacturing process, that lowers embodied. The outcome, I think, was successful in showing that if you spend a little bit of time thinking about these things, you can really see major reductions. And really the point of the study was to share what we found so that people can make these decisions very easily. Like now you have all the information in front of you, but you can kind of skip the calculations and the banging your head across different manufacturers and whatnot and get straight to these low-hanging fruit decisions.
Okay. And I read the study. We'll put the link to the study in the show notes. It sounds like you guys had the significant reduction with something like 20 to 45%, if I remember correctly. Is that the sort of reduction you're talking about?
Yeah. And that falls in line with a study that came out that was more general. It wasn't like a project specific case study, but the Carbon Leadership Forum, the folks that have kind of rang the alarms and set out some of the framework and tools for calculating embodied carbon, put out a study that showed that with no cost increase, you could get anywhere between 20 to 40% reduction in embodied carbon just by making better decisions.
Hey guys, just another quick note from our sponsor, Nexus Labs, and then we'll get back to the show. This episode is brought to you by Nexus Foundations, our introductory course on the smart buildings industry. If you're new to the industry, this course is for you. If you're an industry vet but want to understand how technology is changing things, this course is also for you. The alumni are raving about the content, which they say pulls it all together, and they also loved getting to meet the other students on the weekly Zoom calls and in the private chat room. You can find out more about the course at courses.nexuslabs.online. All right, back to the interview.
So what were some of the low-hanging fruit things besides the CMU that you mentioned?
Yeah, so concrete was a huge one. Reducing and simplifying the refrigerant runs. So this building used centralized VRF systems with what would typically be a ton of refrigerant lines running around to connect the outdoor condensers to the indoor fan coil units. And I appreciated the book behind you when we first got on. But if anyone's read that drawdown book, they know that refrigerant is like the number one drawdown opportunity just globally. The emissions that we put out with tiny leaks of refrigerant have a huge global warming potential. And so it's one of the areas that if you can just reduce the amount of fittings and the length of lines of refrigerant in a building, you have cut down a lot of potential carbon emissions through refrigerant leaks. Another way is to just, again, reduce or optimize your insulation. So we were able to reduce our roof insulation, our wall insulation. We were able to keep double pane windows instead of going to a triple pane by just optimizing the U value, so like the thermal resistance value, with the solar heat gain value to kind of help keep our loads right for heating and cooling. There's other low-hanging fruit just in like decisions you make on finishes, drywall, the density and weight of drywall and the material that goes into it, the flooring and paint and whatever other finishes you use. And I think the biggest opportunity is sourcing things more locally. So
reducing the transportation piece of it. Okay, cool. So what were the sort of ways in which, and you mentioned this a little bit, people can just take your lessons learned and implement them, but how does the industry need to change in the way that we mentioned two of them actually, which is take your lessons learned, but also this new sort of what I think is new, this sort of energy modeling with the EPD, with the embodied carbon considered in the process. What are the other ways in which the industry needs to sort of change to sort of accommodate these insights?
Yeah, I think one of the general ways is just to, again, like take a step back and pause and think about doing things differently and not doing things the way we've been doing them because they work. And that's a great argument, but we know now what we didn't know even 5 years ago. So just having these conversations, right? Again, as simple as like putting in spec language that requires a contractor to go out to a couple of different vendors or manufacturers and ask them questions, maybe make them go through the EPD process if they haven't, right? That's a voluntary process that not all manufacturers do. So we don't maybe have the numbers that we need on a product. The more we talk about this, the more we ask these questions, the more kind of market penetration we're going to get. And the more we're going to bring down costs for like better alternative options.
Absolutely. Yeah, I could see just I mean, a specifier could just put the person has to have their, data published in order to be selected on this project, or those types of things could, transform the supply chain pretty quickly.
Yeah. And we're seeing that. I'll just make a quick plug on the policy side. We are seeing that New York just recently passed a legislation that requires any like big capital infrastructure projects to source low carbon concrete. And so like this is going to really be that shift and that push that suppliers in New York are going to just have to kind of change with the times.
Got it. So your case study also mentioned there's an equity component to this. Can you talk a little bit more about that?
Yeah, so just this project being an affordable housing development, the importance there is cost compression and making these decisions that benefit the planet for sure, benefit the tenants and the users of a building, but also make this cost effective so we can continue to create new affordable housing at a lower cost instead of having to make kind of worse decisions to keep costs down that have a negative effect on carbon. And the funding that we got from NYSERDA helped to kind of offset some of those costs as well to the developer, who's, by the way, a nonprofit who also provides like social services and community services to the tenants and to the communities that they develop and work in. So just providing these things to people that need it, that need to be housed. And then the other component is, I think, education and awareness, right? There's equity is opening up opportunities for people to learn about and know about these things. And I always say from like a workforce development kind of standpoint, we're opening up information in an open source way that gets it in the hands of anyone that's interested.
Very cool. Very cool. Okay, let's go over to the operational carbon side. Sounds like you're working on a lot of projects that are designed to reduce operational carbon as well, not just kind of focused on EC, which has been sort of neglected, right? I think a big thing right now that I'm sort of nerding out on and thinking a lot about, not just with my house, but also just as the industry, the commercial buildings industry as a whole, which is electrification. So can you talk about kind of the trends and technologies you're seeing right now on the electrification side, and maybe start with the laws in New York that are sort of forcing people's hand here?
Yeah. Again, an example of policy for good.
Yeah.
In some ways, just forcing good change. So New York City recently adopted a local law 97, which puts a carbon emissions cap on buildings over 25,000 square feet, and it basically requires existing buildings to do energy retrofits and bring down their operational carbon. It's also requiring even new buildings and buildings under design to be thinking about what those caps are going to be, those carbon caps are going to be. So there's several years where they, notch down the caps that they have in 2024, 2030, 2050. So it's causing people to, and sorry, I should back up and say that anything over those carbon caps gets a financial penalty, right? So you're paying for any amount of carbon you expend over those caps. So it's putting a price on carbon, and it's really forcing people's hands in reducing their carbon. And there was another local law recently passed that banned fossil fuel use in new buildings. So that's, changing the if we're just talking about design decisions, it's changing the landscape and really pushing for electrified systems. Electrification has come a long way in the past, really few years. In the last 3 to 5 years, what was before a very hard nut to crack on the domestic hot water side, there was previously not a lot of good options out there other than electric resistance, hot water heaters. We now have really great heat pump technology to electrify domestic hot water, and we're seeing that evolve at a great pace. The one, I guess, caution about moving to heat pumps, both on the domestic hot water side and on the heating and cooling side, is of course the refrigerant.
That's what I was just going to ask you. Yeah, we just talked about that.
Yeah. So we've electrified a ton of systems, and we've had refrigerants around for a while. Any split system with cooling uses refrigerant, but the key is what kind of refrigerant are you using. The typical R410A that we've seen that was better than the ozone depleting refrigerants of the past is still much worse in terms of global warming potential compared to actual CO2, which is a 1-to-1 equivalent in terms of emissions, whereas our 410A is like 2,000 plus ratio of carbon emissions. So all that is to say that we are seeing innovation on that side, especially with domestic hot water, of using CO2 as a refrigerant instead of some of these more harmful refrigerants. Okay. And so that's a huge development where we can now design large central domestic hot water systems that use CO2 refrigerant and fully electrify with the benefits of heat pump technology, inverter-driven heat pump technology.
Got it. Is it going more towards, because I'm looking at a heat pump water heater for my house, and it obviously rejects cold air out into the ambient space that it's sitting in. Are there heat recovery options here that are connecting different loads in the building together versus them being siloed in the past, or how's that work today?
Yeah, that's an interesting question. I mean, so there are different technologies out there. Some of them have those condensers on the exterior, so you're not, drawing down your ambient heat. And some of them are packaged, so you'll have that inside, and then you have to worry about how much it lowers the temperature indoors. For the most part, the exterior application where you have the condenser on the outside is preferable because of that, because it doesn't throw off your heating and cooling loads. But you can take advantage of that in a building where you have very varied kind of load profiles and program and use in a building. For example, if you have a data center,
constant cooling load year round.
Right. Just anywhere where you have high internal heat gains from equipment or people or whatever it might be, you can use that to your advantage. I recall one project, and apologies, I can't remember the name of it, but it was in Albany, I believe, that put in the outdoor condensers of a heat pump water heater into a commercial kitchen space and was using the reject heat from that space to heat its hot water in a much more efficient way in a residential building that happened to have a commercial kitchen on the first floor. So
got it.
Yeah.
Cool. So what do you think? So when I think about electrification, I don't think new buildings are that hard. Maybe they are, but it doesn't feel like they're the big challenge. What do you think the big challenges are, and the ones we need to get around with respect to electrifying existing buildings?
Yeah. You're right. It is.
Okay.
We've figured that out. There's like and that fossil fuel ban in New York kind of points to it. Like there's no reason we should be putting in new gas lines and
Mhm.
designing gas into new buildings. But on the existing building side, it's harder because really the biggest hurdle is the existing electrical infrastructure and
Yeah.
having to upgrade for the loads that would carry heating, cooling, hot water, and anything else you're potentially electrifying from oil or gas system. And then so that's one side, just the electrical load of the building and that infrastructure. And then whatever existing infrastructure you have, whether it's hydronic distribution or steam distribution, you have to retrofit that to a new whatever it might be. Heat pumps are a little more straightforward, and you can kind of just ignore the existing distribution you have. But ideally, from a cost perspective, you'd want to look at how you can reuse the existing distribution system. And that becomes harder to find equipment that's plug and play with whatever existing distribution you have. Just you can't just throw in an electric heat pump. And
Yeah.
so that becomes difficult. So yeah, I'd say electrical infrastructure and distribution
Yeah.
are the big hurdles.
The challenges I see, and I'd love to get your take on this. I'm viewing this kind of through the lens of my own just residential water heater, right? So the big challenge I see beyond, I mean, those that you just mentioned are huge. Like for instance, I have to do $2,000 of electrical upgrades just to do a heat pump, just to start. But set that aside, I feel like there's challenges in that now, instead of calling a plumber, I'm now the GC, right? I now have electrical sub, a plumbing sub, and potentially an HVAC sub if I need to get the rejected air somewhere else, right? So that I'm now like this project developer. I think that's a big challenge because you're now involving all these different trades that you weren't before. The other challenge is similar in that I can't find anyone in the local supply chain that has done what I'm asking them to do before, right?
Yeah.
So there's almost like this. And then once I've found people that are willing to do it, even though they haven't done it before, they're giving me a price premium because they're unsure, right?
Yep.
And I'm sitting here going, I know what this is. I know what the scope is. There's no reason that your labor cost is double than what it was before with the gas. It's just because you're more comfortable with doing what you've always done. And so now I'm having that conversations, right? Which I guess is the role of the GC, right? Because I am the GC. But I feel like it's a big challenge for people. You can talk about homeowners, but let's take this to the commercial industry, right? How are we going to get around those sort of supply chain challenges at scale in every city, right? That makes me feel very overwhelmed. What do you think?
Yeah, it overwhelms me too, and it overwhelms developers who. So you hit the nail on the head, and that's exactly where I was going to take this. Like you take a homeowner scenario and you scale that out
Yeah.
to massive buildings, and it becomes even more complicated and costly, right? Talk about a cost premium for the risk of the unknown, the challenges and some of the things that asking NYSERDA to fund, for example, is workforce development and training contractors in
Yeah.
this work so that they can feel more comfortable, bring their costs down. The other part of that is the ongoing maintenance and operation, right? There's a risk that you take on with this new equipment and not
Mhm.
knowing what the true lifespan is and who's going to service that and at what cost for the ongoing for its useful life. And that's a big cost hurdle that people are not yet we haven't gotten over yet. And that's workforce development, it's education, it's knowledge. The other side is the cost of electricity hasn't come down in certain places that makes it make sense yet. So
Yeah.
I talked earlier about cleaning up our grid, but like cleaning it up and making electricity cost effective, whether that's like starting to do kind of like rate subsidies to begin with to get people interested and help them bring down the first cost by knowing that they can lock in at a good electrical rate down the
Mm.
line where there's you don't know what's going to happen 20 years from now in terms of what you pay for electricity. So that's equally as important and as much of a hurdle on the cost front.
Can I ask you a moral question right now on the air? Put you on the spot with my personal problems. So if I look at my project in particular, it's like a perfect microcosm for all of this, and I'm planning to write about it, but it doesn't help me figure out exactly what to do, right? So what you just said, we have a really high electric rate. We pay 14 cents a kilowatt hour. and we have a really low gas rate. It's like $1 a therm or something ridiculous. And so what that means for me right now is that it's actually, there's no savings for going from gas to electric to heat pump water heater, even though the heat pump is 3 whatever times more efficient for making hot water. There's absolutely no savings for me right now. So, and the cost is 3x. So the cost is 3 times, given the electrical upgrades, given the contractor premium, and given the fact that the heat pump costs more than the old style water heater. So three times. So I'm spending essentially about $4,000 extra for no savings today, right? What would you do? What's the right thing to do, I guess?
Yeah, I mean, the right thing to do is to idealize this future state where maybe you add solar or some other renewable energy to your house and you're able to kind of bring down your electrical costs, and morally that you've cut the line with fossil fuels. But you're speaking to a passionate sustainability nerd who thinks about those things. And I will say, listen, I feel you. I live in a house that was built in 1900, and I've had to make these decisions in real time. And sometimes your back's against the wall and you don't have that extra $4,000, and you have to make a decision that just kind of gets you eating in the winter when you need it. So to that, I say, and this kind of maybe answers your previous question about existing buildings. Like, maybe you can't do it all. Like, maybe you're not ready to switch to a heat pump water heater, but like, start with upgrading your electrical service. And then when you have the money, like, work on to the next thing. Same thing on the existing building side. Start with electrifying one thing, or updating your electrical loads for the future capacity that you're going to want to get into down the line, even if you don't have the money to do it now. Yeah.
I love it. Cool. That was a great conversation. I'd love to end with some Carveouts. So what TV show, book, podcast, movie would you recommend to the audience? I'll go first. So one of the ones that I'm reading right now, and I'm not that far into it, but it's called After Cooling. And it really relates to, it's a book called After Cooling. And it's written by a journalist. So it's really fun in the way that he explains all the things that people like us live, eat, and breathe every day, but he's explaining refrigerants to a layman audience. But then he's like going to the source. So he's going to people that are selling refrigerants on the black market, like R12. He's going to those people and he's like participating in those transactions. And like, it's a really fun read from that perspective, because he's getting down into the ground of this issue. But that's about where I'm at. I'm like 20% through the book, but it's a really good book in that it talks about all the challenges you were talking about earlier from a refrigerant and emission standpoint, and the leaking. Huge deal.
Yeah, very cool. I haven't heard of that. I'll have to check it out. Yeah, related to embodied carbon, I would recommend A New Carbon Architecture by Bruce King and others. It's a great overview. What was that?
That's a book?
Yeah. Okay. That's a book that gives a great overview and breaks down in great detail, like, every building component and how you could draw down carbon.
Cool.
And then book I'm currently reading that I've hardly gotten through the first couple of chapters, but it's called Healthy Buildings. And just in general, I don't know if you've heard of My House is Killing Me. Those types of books that deal with indoor air quality are equal parts scary and informative.
Oh yeah. Yeah, absolutely. Yeah, the Healthy Buildings book is one that's come up before, definitely on the podcast and in the community. Definitely recommend it for sure.
Yeah. Speaking of podcasts, I will plug the Passive House Accelerator podcast. The Passive House podcast, I believe, is what you can look it up on the streaming services, but they are deep into this world and put out some great content.
All right, Carmel, I appreciate you coming on the show and teaching us all about all these things that we don't normally talk about.
Yeah, thanks for having me. This was great conversation.
All right, friends, thanks for listening to this episode of the Nexus Podcast. For more episodes like this and to get the weekly Nexus newsletter, which, by the way, readers have said is the best way to stay up to date on the future of the smart buildings industry, please subscribe at nexuslabs.online. You can find the show notes for this conversation there as well. Have a great day.